We're the Electric Narwhalzz. We found that a lot of women nowadays are having trouble with hairdryer purchases. They tend to buy them based off aesthetics because most of the time they are the same price and are seemingly the same. We decided to do some testing to find out which of the three hairdryers is really the best. Each brand tested has a wattage of 1,875 watts. First, we have the Andis brand hairdryer. Next, we have the Vidal Sassoon brand hairdryer. Last, we have the Revlon brand hairdryer. We will be running 5 tests on our hairdryers. The first test is a test for velocity. The second test is a test for maximum temperature output. The third test is a test for temperature efficiency. The fourth test is the test for cool down process. And the fifth test is the test for the decibels emitted. We will run each test 3 times through.
To do proper testing, we need to make sure that we had all the proper equipment. A thermocouple was used to measure the temperature of the heat output. The data was recorded using a program that we'll discuss later. We used the anemometer to measure the velocity of the output. A decibel recorder was used as well, but we'll see that in our testing video. Using SolidWorks, we designed an apparatus that would be used to hold all of our equipment in one uniform place. Having this apparatus made it so that we only had to move the hairdryer when we wanted to change it out for next test product. The thermocouple and anemometer remained unmoved throughout every test performed. Our hairdryer is placed in an adjustable holder outside of the box and then duct taped down so that it doesn't move. The end of the nozzle of each hairdryer was lined up with the edge of the box. The thermocouple hangs through a small hole in the top of the box, and since each hairdryer's nozzle is at the edge, it is always a uniform distance from the heat source. The anemometer is placed at the exit hole of the box, which is also a uniform distance from the hairdryer. We install the decibel recorder application on our phone and place the phone right next to the side and front of the hairdryer so to simulate what the hairdryer would sound like to the user. Throughout all the tests, the phone was placed in the same exact spot so we could keep a uniform distance in order to have the most accurate data. The thermocouple, as described before, is connected to a computer program called LabVIEW. This program records the temperature within our apparatus of a period of time, and this program allowed us to generate hundreds of data points per run. As you can see here, we have a stopwatch running in the computer next to an open Excel sheet. Every 30 seconds, we recorded the reading on the decibel app and on the anemometer into our Excel spreadsheet with all of our data.
To run our first test, the test for velocity, we set up the hairdryer in the box apparatus with an anemometer. We placed the anemometer in the exit hole, turned on the hairdryer, and recorded the velocity every 30 seconds. For test number 2, the test for max temperature output, we set up the hairdryer in the box apparatus with a thermocouple. We placed the thermocouple through the top hole of our box apparatus, started the hairdryer, and had the program LabVIEW record the temperatures over an extended period of time. To find the maximum temperature, we looked at the graph of the temperatures over the period of time and looked to see where they plateaued. This was our max temperature output. Test number 3 and 4 are set up the same way as test number 2. We had the hairdryer in our box apparatus with a thermocouple through the small top hole. We used the program LabVIEW to record the temperature over an extended period of time. For test number 3, to record the temperature efficiency, all we have to do is evaluate the time it took to reach 90% of the max temperature. This value will give us the efficiency of each hairdryer. To record test number 4, the time it takes to cool down, all we have to do is evaluate the time it takes after we turn the hairdryer off to return back to normal temperature. To run test number 5, the test for the decibels emitted from the hairdryer, we set up the hairdryer in a box apparatus and used the recording device app from our phones. We placed our phones right on the outside of the box apparatus near the nozzle of the hairdryer to simulate where the hairdryer would be near your ear. And every 30 seconds we recorded the decibels emitted and placed them into our Excel spreadsheet data plot.
Using these 5 tests, we'll be able to accurately come up with a rating formula to determine which hairdryer really performs the best.